Hello there, grade 7. Welcome to some online learning. Hopefully, this is going to work for us. We'll make it up as we go. And if you've got questions, please make sure that you're getting in touch with me because I want to make sure that you're understanding what we're doing. So we already finished our probability stuff, well, mostly anyway, but we sort of finished quite abruptly. So I thought it might be a good idea to do some review. So we're just going to review the probability stuff that we've done and make sure that we remember what we're all talking about. So we had a nice little number line that we looked at a while ago where this was 0. Well, let's call it percents. So that's 0. This is 100%. So obviously in the middle is going to be 50%, and then halfway between those and halfway between those. So we're going to call this 25% and 75%. And we talked about the fact that we have mathematical language that goes with each of these percentages. So if it's on 0, it's impossible. And if it's 100%, it is certain. So those were the words that we used. Now, if it was 50%, we used the word even chance. Hopefully we remember that language. Now, if it was about 25%, we called it unlikely. And if it was 75%, we called it likely. Making sure we can see that. Yep, great. Okay, so those are the words that we want to be using when we're talking about percentages. Let's just leave it at that. Now, remember you can have decimals as well. So this would be 0 and 1, and 50% is 0.5, 25% is 0.25, and that makes 75% 0.75. So we can talk about them in terms of decimals or percentages. It depends on what the question is asking for. So then if I'm asking, what is the probability, let's say I'm rolling a dice, what is the probability of getting a 2? Well, when we want to find the probability of something, what we do is on the top of the fraction, we put the things we want. And on the bottom of the fraction, we put the total number of things. So in this case, what we have is the things we want. Well, there's only 1, 2. And the total number of things, well, there are 6 things on a normal die. So we say it's 1 over 6. And we can leave it as a fraction. If the question asks you to do it in decimals, then you can, but otherwise fractions are really good. And mostly I prefer fractions because you never have to round fractions. And if you want to turn this into a decimal, you can just do short division. So what if I asked for the probability of an even number if I was rolling a dice? Well, how many even numbers are there? There's a 2, a 4, and a 6. So there are 3 even numbers out of a total of 6 possible numbers. And 3 over 6 is the same as 1/2. So every time you can simplify a fraction, please do that. All right, so what if I said, so let's go back to this example. So the probability of getting a 2 was 1/6. So if you remember this little symbol, if I just do a little 1 there, it's the complement. It means not. So what is this means? What is the probability of not getting a 6? Sorry, not getting a 2? Well, if there was a 1 in 6 chance that I would get a 2, there is a 5 in 6 chance that I won't get a 2. And when you have something and its complement, they should always equal 1, right? Because that is the total number of things that could possibly ever happen. Either it's going to rain or it's not going to rain. There is no other possibility. It can't kind of rain. It's either raining or it's not, right? So you're either throwing a 2 or you're not. There's no other possibility there. So together, all of those things must add up to 1. So that's what's known as a complement, right? With an E. Remember the other version of complements with an I, and that's when you say something nice about them, like, oh, Miss Oren, aren't your videos fantastic and informative and so entertaining? That would be a compliment with an I, which of course you're all thinking, I know. So, hopefully we remember how to do that. So, what if we're doing 2 different events? Remember we did this thing called a two-way table. So what if I toss a coin and I roll a die? So what I want to do is create a two-way table that's going to show me every possibility. So here I'm going to do the coin so I can have a head or a tail. And here I want to roll my dice. So I could have a 1, 2, 3, 4, 5, or a 6. And then I'm just going to make a little table out of this. Okay, so what I want to do is write down every possible combination of things that could happen. I could have a head and a 1, a head and a 2, a head and a 3, blah, 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 so on and so on. Then a tail and a 1, tail and a 2, tail and a 3, blah, blah, blah. So then what I can do is I can use this to find probabilities. So how many things could possibly happen? What is the total? Well, I have 12 boxes, right? So there are 6 here and 2 here. So 6 by 2 is 12. So whenever I do my probability, whatever I want is always going to have a 12 on the bottom, right? Because it's out of the total number of things that can happen. So what if I asked for the probability of, let's say 3? So how many times does a 3 happen? Well, it only happens twice. You can get it with a head or you can get it with a tail. So 2 out of 12 times, I could end up with a 3, which is the same as 1 out of 6. So there's a 1/6 chance that I will end up with a 3 at the end of it. So what is the probability of getting a tail? How many times does a tail happen? Well, it happens 6 times out of a total of 12 possibilities. And then again, I can simplify that and it becomes 1/2. These are really useful when you have lots of information that you're not sure about. So what if, let's do one where I have a lot of possibilities. So let's say I'm going to roll 2 dice. Then I can have 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. So you can see there are a lot of different combinations going on here. And without counting the boxes, we should know how many total possibilities there are because it's 6 times 6, right? So there are 36 options going on here. Now, depending on what I'm asked to do will depend on what I write here. If I'm asked to find the total sum of the dice, well, I would write 2, 3, 4, 5, 6, 7, and then, 7, 8, 9, 10, 11, 12, blah, blah, blah. I would fill this out based on what they were adding to. But if I just wanted to know what they were showing, I might write 1 and 1, 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6, 2 and 1, 3 and 1, 4 and 1, 5 and 1, 6 and 1. I'm not going to fill the whole table out, but you get my point. Then when I'm asked to do probabilities, I can just look at my table and count how many times something happens. So these are a really useful way of looking at large amounts of information. What else do we want to do? Oh, so these are the other 2 words that we looked at. Remember the 2 types of probability? I'm going to give you 2 seconds to try and think about the 2 different types of probability. One of them starts with a T, the other one starts with an E if you need a bit of a hint. All right, so this one here is theoretical, which makes this one down here experimental. So these are the 2 types of probability that we're looking at. Theoretical probability is what should happen, and experimental probability is what does happen. So theoretically, let's go back to this example. Theoretically, if I toss a coin and roll a die, I should get a 3 1/6 of the time. But if I actually do that experiment, there's no guarantee that that's actually going to happen because, well, life is not as predictable as we might like it to be. So it means that we should roughly get that. I mean, if I toss a coin 20 times in a row, I could get 20 tails, but that is very, very unlikely. But it is absolutely possible because experimental probability does not always match theoretical probability. That's mainly what we covered this topic. So hopefully you remember those things and yeah, we'll try and do some activities and see if you can put it all together. Good luck.